Today we're starting chapter 7, which is over systems of equations. So if you look at this word systems, it's plural, and equations is plural. So instead of having one equation, you're going to have multiple, at least two. And so what you need to understand is that a system of equation is where the lines intersect. That's your answer. So right here, I want you to put a little thing in that put the answer is the point shared by both graphs, which is also known as the intersection. The answer is the point shared by both graphs, which is also known as the intersection. All right, so right here in example 1, where would you find the answer?
Where they cross.
Where they intersect. Right here is the solution because that's what point satisfies both equations. So this is your solution. So if this is the x-axis and that's 0, what is this coordinate's x value? What is the x value? 3. What is the y value? All right, if you are given a graph and you only see one line, then and they ask for the answer to the system of equations, then that means the lines are like overlapping each other. So there's a line here and then there's like one right on top of it. That is called all real numbers, the answers, because it's going to touch all over the spot. They have the same slope and they have the same y-intercept. So your answer could be all real numbers. It could be infinite solutions. There's different ways you can word that. So just know that you could answer it pretty much like any of those. What happens when you have parallel lines? Will you have a solution? They will never intersect. And so when did we learn this? We talked about this when we were learning how to solve equations on paper. Yes? And now we're kind of looking at it from a graph's perspective. So you've kind of already been introduced to this. But when you have parallel lines, your answer will be no solution. Okay, these are parallel lines. They will never intersect. So they will never have a solution. They have the same slope, but they have a different y-intercept. Today we're going to learn how to solve systems of equations by graphing. There are many ways to solve systems, okay? And one way is to stick them in your calculator and y equals. Do y'all remember how to solve equations in your calculator? Go to y equals, put in one side is y1, one side is y2, hit second trace, option 5, enter, enter, enter. Remember that? But today I'm going to teach you how to solve them by graphing. I don't even know where this page came from. All right. So the first thing you're going to do on these, it wants us to solve the equations by matching. So this looks like your homework. That's why it is. Okay. So everybody look at this first example. If I want to match, this is going to look like your assignment. Okay, so this is like an example of what you're going to see. If I want to match this equation with one of these graphs, what's the first thing I should do? Rearrange it. So write that up here. Rearrange to y equals mx plus b, because you guys are really good at y equals mx plus b. All right, this one's easy to rearrange. Do y'all see it? All I need to do is pull the negative 2x to the right. So I have y equals positive 2x plus 6. Now I need to rearrange this one. So I'm going to come over here. How would I move this 2x? So I have 3y equals negative 2x plus 2. How would I get rid of the 3? Divide everything by 3. So this equation one would be y equals negative 2/3 x plus 2/3. Now we're going to go match one of these graphs with this system of equations. I'm going to check this one first. How can I check this? What is the y-intercept of this one? So everybody find the y-axis. Is there a y-intercept of 6 on this one? No. So let's go over here. Does this one have a y-intercept of 6? All right, let's go over here. Does this one have a y-intercept of 6? Yes. So let's check the slope. Does it have a rise of 2 and a run of 1? So it's got to be this one, and then you can also go check that one. Does that one look like it has a y-intercept of 2/3? Yes. So this first one, let's label these A, B, and C. So this first one has an answer of C. Do y'all understand how to match them with a graph? Let's go to the next one. How would I rearrange this one? Yep, so I have y equals negative 2x plus 2. This one, I would move this over by subtraction. So I have negative y equals negative 5x minus 9. And what happens if I have a negative y? Divide by negative 1. So everything just becomes opposite, right? So y equals positive 5x plus 9. I haven't done it. So go see if you can figure out which one that one matches to. Okay, so can y'all see the y-intercept for the plus 9, or could it possibly be it right here? See how it's going up there? So it's probably that one, but I'm just going to check this one. So here is a y-intercept of 2, and it has a rise going down to right 1, which is negative. So this one has to be B. Do y'all understand this? All right, this one I'm just going to double check, and I'm just going to check this one. So y equals negative 1x minus 2. And if you look, here's a y-intercept of negative 2 and a rise over run of negative 1. So there's A. Do we need to do another example like that? Yes, down here? All right, y'all want to try it on your own? All right, go. I'm going to pause this. Okay, so check to make sure that you rearranged your equations correctly. I can see the answer to this one right away. And can anybody tell me why? They both have a y-intercept of positive 4, which means they're going to meet at that spot. Does that make sense? So if you look at C, they are both touching the y-axis at 4. So that has to be C. Okay, and then if you look at, what was your strategy for this one? Because you couldn't use the y-intercept really, right? So you looked at rise over run, yes? So this one, I looked at the fact that this could possibly have a y-intercept of -8 because it's like going to cross like right here. And then I said, well, is the slope 3/2? So up 1, 2, 3/2. Yes, it is. And this one also could have a y-intercept of 18 because it's going to be way up there. Check the slope, and it was 5. So this was A and then B. Okay, now we're going to solve them by graphing. So the first thing you need to do is rearrange to y equals mx plus b, then graph. Okay, so this equation, I have y equals -2x plus 6. This one, I have -y equals -2x minus 2, and then I've got to get rid of the negative. So it's just all going to become positive. Now, if you want, you can graph in 2 different colors so that you have 2 lines in different colors. I'm just going to use pencil and red pen. So this one I'm going to graph in red pen. My y-intercept, my slope is -2/1. My y-intercept is 6. Do y'all remember how to do this? So where do I start? At the y-intercept of 6. So here's 0, 0. So 1, 2, 3, 4, 5, 6 is my first dot. And then my rise is going to be down 2, because that's a negative, and right 1. So down 2, right 1. And then keep going. Down 2, right 1, down 2, right 1, and so forth. And these graphs kind of got distorted when I made the copy, so you can kind of see it looks like it has a little curve in it, but that's just because the graphs got distorted. Okay, when we graph, should we use a straight edge? Yes. I'm going to do the next one in pencil. So my slope of this one is 2/1. That's positive, so it's going to be going up and right. And my y-intercept is 2. So I'm going to go to the y-axis to 2 and put a dot. I'm going to rise up 2 and right 1. What did you notice right there? That's the answer. That's the solution. That's where they intersect. So up 2, right 1, up 2, right 1. I'm going to put my line through it. But that is the answer right here. That is your solution. So all you have to do is figure out what that point is. So on the x-axis, what is that point at? 1. And on the y-axis, what is it at? Can you check this in your calculator? Yes, and I taught you this at the beginning of the year. Once you have your equation in y equals mx plus b, you can simply go to y equals, put in this equation, -2x plus 6, then go to y2 and put in this one, -2x minus 2. Hit second trace, option 5. Wait for it to graph. Did I put it in right?
When you put negative on the second one, it's 2x plus 2.
Oh, it was supposed to be positive. Yeah, I was like, there's no way that's right. Here we go. I made them parallel on accident. There we go. Hit enter, 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 and there's your answer, 1,4. Yes, are we good? All right, let's try the next one. How do you graph an equation when it says y equals -2? It's going to be, yes, it's either going to have a 0 slope or an undefined slope. And if it says y equals, that means it passes through the y-axis at -2. So go on the y-axis to -2 and put a dot. It's going to pass through the y-axis right there. If you ever get confused, simply make a table. So if you ever get confused, you can say, hey, the y always has to be what? Yeah, so then you could go -1, 0, 1, and that will help you graph it if you ever get confused on how it should look. All right, for this one, I need to do what first? Rearrange it. Okay, I need a slope. What's the slope? 3/1. What's the y-intercept? So I start on the y-axis at 1. My rise is going to go up or down? Up and right. Or down and left. If I want to see where the intersection is, which one should I do? Yeah, down and left. So down 3, left 1. Do you see the intersection? Right there. Up 3, right 1. And again, here is my solution. So what is that coordinate of this dot right here? -1, -2. Can I have checked that in my calculator? Yes. Do you want to try the next one on your own? All right, go. Remember when it says x equals 2, go to the x-axis, put a dot there, and the line will pass through the x-axis. Did everybody get the answer of 2, -3? Yes? Do we want to do any more? They're all the same.
No.
Does anybody want to do any more?
Oh, I did one.
One more?
Yeah.
We can do one more. But we'll just do one more.
That's that one.
Let's do one more and then we're done. You want to try it on your own? All right, go. after you rearrange these equations, tell me what you think.
Same slope.
They have the same what? But different y-intercepts. So what kind of lines are these going to be? They're going to be parallel. So what would your answer be? No solution. Real quick, y'all don't have to do the next one, but look what happened when I rearranged them. They have the same slope and the same. So when I graph them, they're literally going to be on top of each other, so my answer would be all real numbers. All right, everybody look at 1 through 6. 1 through 6 says, tell whether the ordered pair is a solution. There are 2 ways to do this. Number 1, you can rearrange the equations to y equals mx plus b, stick them in your calculator and see if it's the solution. Yes? Or you can plug in 0 for x and negative 4 for y, and it has to work for both equations. Okay, so I will show y'all what that looks like both ways, and then you decide which way you want to do it. So what's the first way I said you could do it? You got to rearrange. So I would rearrange this one, and it would be y equals negative x minus 4. I would rearrange this one. It would be negative 5y equals negative x plus 20. And I would divide by negative 5. And I'd have y equals 1/5 x minus 4. Yes? Is that what y'all got or no?
Yes.
I go to my calculator. I put in y equals. I go to second trace option, because what does option 5 say? Oh, no, it says I want the intersection. I wait for it to graph. I hit enter, 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 and what is the intersection? So was this the actual intersection for both of them? So what's my answer going to be for number 1? Yes. Now, I'm going to show you all the other way you could do it. I could test out 0, negative 4 for this equation. So plug in 0 for x. So 0 plus negative 4 equals negative 4. Is that true or false? That's true. If this is a solution, it also has to be true for this one. So I would say 0 minus 5 times negative 4 is equal to 20. Is that true? Yes. Was it true for both of them? You decide which way you want to do it. You can rearrange, stick in your calculator, or you can plug in for both equations, and it has to be yes for both to get a yes. If it's a yes for one and not the other, then the answer would be no.
Which one do you think is easier? Huh?
I don't know. You decide which way is easier for you. Are you really good at rearranging?
I don't know.
I don't know what to say. Okay, 7 through 12 are just like the first examples we did. You're going to match the system to the graph. So you're going to rearrange first and then match the graph. Yes? Please write the answer. So like if 7 is A, write like A right here and like circle it. If the answer to 7 was this graph, then put A right here. I don't know if it's A, so please don't put it, but
It probably is A. Yeah.
it's on your notes. At the bottom, use the graph to solve the linear system. Oh, they want the actual answer.
So a coordinate.
That's all they want. Look, number 13, this is the graph. Here's the answer. That's so you. What would you write as your answer? That's your answer. 2, -1. Those are the easiest ones because they give you the answer. Okay, when you flip to the back, it says, solve the linear system by graphing. So you're going to go graph, and then you have to have an answer. Guys, if you just graph it, that is not an answer. So if you look at your notes, when we did these, we always had a final answer. So look at this one right here. I did all this work, but that's my answer. Does everybody understand? If it's parallel, you're going to write no solution. If it's the same line, you're going to write all real numbers. But you have to have an answer, which is a coordinate of where they intersect. Does everybody understand? Then let's do 22. It literally gives you the answer right in here, I think. And then take off 23. I already marked it off. Get busy.